So for this problem, we want to find the points that are both polar and rectangular form at which the polar curve r equals 4 cosine theta has a horizontal or vertical tangent line. We're going to sketch a graph. Well, the graph is already sketched, but we're going to add the lines to it. Find the Cartesian equation of those tangent lines. We only need to consider a single period to find these solutions. Right, so we're not going to talk about loop-de-loops going around and around this thing. We're only going to talk about one period going around. All right, so notice really quickly that r is equal to 4 cosine theta. That means that f of theta is equal to 4 cosine theta, which means f prime of theta is the derivative of that. The derivative of cosine is negative sine. And I need that for my lovely formula for the slope of a tangent line. It's not quite the derivative. I mean, it's the derivative of dy dx, right? So the derivative of r is right there, but this is more complicated. So I'm going to use those two pieces here. So I'm going to say that this is equal to f prime, which is negative 4 sine of theta times sine of theta, plus f of theta, which is 4 cosine theta times cosine of theta, over f prime of theta again, so that's negative 4 sine of theta again, times cosine of theta, minus f of theta, which is 4 cosine theta times sine of theta. I don't need to do anything more. This is fine, right? It doesn't have to be simplified or anything, because I'm just going to be plugging things in, right? Okay, so let's think about this. When I want vertical tangent lines, the vertical tangent lines are going to have a denominator equal to 0. So let's start with the vertical. You'll notice that this problem is going to take us 2 pages. We'll do vertical tangent lines on this page, and we'll do horizontal tangent lines on the other page. So this is M right here. We could put it in a little box because we're going to keep referring to it. Okay, so the vertical tangent lines will have the denominator equal to 0. So I'm going to take that denominator, which is negative 4 sine theta cosine theta, minus 4 cosine theta sine theta. I'm going to set it equal to 0. Okay, they're like terms, so negative 8 cosine theta sine theta is equal to 0. So either the cosine of theta is equal to 0, right? Because negative 8 is negative 8. That's never going to be 0. So either the cosine of theta is 0 or the sine of theta is equal to 0. Multiplication property of 0 is still true from algebra class. If two things are multiplied to be 0, either one of them is 0 or the other one is. Now, if the cosine of theta is 0, that happens at pi over 2 and 3 pi over 2. So that would mean theta is pi over 2 or 3 pi over 2. If the sine of theta is 0, that means theta is 0, pi, or 2 pi. Now, I want to consider the period at this point and kind of think about this graph for a second. So let me pull this graph up. Okay, so when I draw this graph and I bring it around, I want to know how large the period is, because the period will help me because I can limit myself. Oh, look at that. I can limit myself to pi. Look, 0 to pi is my period, because right around 3.14 I have the full graph. Very nice. Okay, so that means a single period. So notice the period equals pi by Desmos, right? Oh, very nice. Now, how does that help us? That means that we can kick 2 pi and 3 pi over 2 out to the curb because they're not in the period. Nice. Okay, so that gives us 0, pi over 2, and pi. We have 3 angles where this would happen. Okay, so we can get the polar points pretty easily because the polar points would be 4 cosine of theta, and we know what our theta is. So if we think about the function, here, let's say, so if theta is 0, r is 4 cosine of 0. Oop, cosine of 0, not cosine of theta. Cosine of 0, which is 4, right? Because 4 times 1. If theta is pi over 2, r is 4 cosine of pi over 2, which is 0. If theta is pi, then r is 4 cosine of pi, which is 4. Negative 4, excuse me, negative 4. Okay, so I have my points. So my r theta points are 4, comma 0, pi over 2, 0, comma pi over 2, and then, right, it goes r theta, negative 4 pi. These are our polar points. Cool, we're like a fourth of the way. All right, we've done it. Okay, so now notice on the graph where these are. Over 4 up 0 is right here. Over 0 up pi over 2 is right here. Negative 4, but swing around pi is right back here. So if I labeled these points, just for the fun of it, like A and B, this one's A, this one's B, this one's A again, right? Okay, well, now how would I get them into rectangular? Because this is all well and good, but you'll notice they want rectangular points too, the jerks. Okay, so let's get them into rectangular form as well. Okay, so for A, and I really only need to do this, twice because these two are the same points, so I don't need to bother. I can just do it once. So for x is equal to r cosine of theta, right? So for point A, let's look at point A. If x is equal to r cosine theta, y equals r sine of theta. Well, my r is 4, right, for point A, right? I'm looking at 4 comma 0, right, for r and theta. Then it would be x is equal to 4 cosine of 0. Y is equal to 4 sine of 0. The cosine of 0 is 1, so that's 4. The sine of 0 is 0. So this actually is the same point in xy coordinates. And you can tell that just by looking at it. I mean, look at that point. That's over 4 up 0. I mean, look at it. Okay. You can imagine the other ones aren't going to be as easy as these. All right, so for B, that point was 0 pi over 2 as our r and theta. So x is equal to r cosine theta, y is equal to r sine theta. So this would be equal to 0 cosine of pi over 2, 0 sine of pi over 2, which any way you slice it is 0 and 0. So point B for x and y is 0, 0. Well, no, duh, it is, right? So here's the xy for point A, here's the xy for point B, right? Look at it. Isn't that the origin? Isn't that the pole? Sure it is, right? So that worked out. No problem. All right, so we've got our rectangular points. So these are the rectangular points. With a vertical tangent. Now, what about the horizontal tangent? Well, we're going to have to go to another sheet of paper. Okay, so before I go, let's think. If I'm going to have a horizontal tangent, for a vertical tangent, the denominator had to be 0. But for a horizontal tangent, the numerator is going to have to be 0. Okay, so let me write that down. So for a horizontal tangent line, the numerator equals 0. And I held off on this one because this is going to be the harder one. Because you can see there's kind of a point up here where it's going to happen. And then there's a point down here where it's going to happen. And we're going to figure those places out. Okay, so if that numerator is equal to 0, that means that negative 4 sine of theta times the sine of theta plus 4 cosine theta is equal to 0. All right, so that would be, let's see, 4 cosine squared theta minus 4 sine squared theta is equal to 0. Factor the 4 out, so that's cosine squared theta minus sine squared theta equals 0. That factors, so that is the cosine of theta minus the sine of theta, and then the cosine of theta plus the sine of theta. And if that's the case, then either this piece is 0, which would mean cosine of theta minus sine of theta equals 0, or this piece is 0. This would mean that the cosine of theta is equal to the sine of theta. This would mean that the cosine of theta is equal to the negative sine of theta. Or in other words, well, let's just leave it at that. Now let's think about the unit circle. Where does this occur? What angles would have cosine and sine be the same? Do you remember? Because they happen, right? And remember, we only want to look in the period of 0 to pi. Let's remind ourselves. Oop, period. Oh, it's 0 comma pi. I'm sorry. I just assumed, right? So 0 pi. Technically, this should be brackets, so I should include them. Sorry about that. Okay, so it's here and here, right? So over at this angle, pi over 4, it's 1 over the square root of 2, 1 over the square root of 2. Or square root of 2 over 2, square root of 2 over 2, depending on which way your instructor had you memorize it. And then over on this side, it's 3 pi over 4. 3 pi over 4 is, oh, I don't know if I can fit it in there. It's negative 1 over the square root of 2, and then positive 1 over the square root of 2. So the same value, but they're opposites, right, which is what this one is. So this one would get us theta is pi over 4. Technically, it also happens down here in this quadrant, but that quadrant's not in our period. So I'll write it down, but I'll cross it off. So 5 pi over 4, not in the period. Ignore it. And then this one would get us 3 pi over 4. And technically, this point down here as well, which is 7 pi over 4. But 7 pi over 4 is not in our period. All right, so those two, not in the period, going to kick them out. All right, so then now we have what we need to make the polar points, because the polar points would be, let me see here, at these two values, right? So at theta equals pi over 4, then we would get r equals 4 cosine of pi over 4, right? Because that's the formula we're working with for this problem, which is 4 times the square root of 2 over 2, or 1 over the square root of 2, depending on which way you want to do it, which is 2 square root of 2. So that means that I have a polar point, and I'll talk about it in a second, I'll number it. So this is theta equals 3 pi over 4. That would mean r equals 4 times the cosine of 3 pi over 4, which is 4 times the negative square root of 2 over 2, or negative 1 over the square root of 2, tomato, tomato, which is negative 2 square root of 2. So if I was going to label the points on our graph, we have one up here, and we have one down here. I'm going to call it C and D, right? So C and D. C is this point, right? And D is this point, right? So I would say C is if we're going to go r theta, it would be 2 square root of 2 comma pi over 4. D is negative 2 square root of 2, 3 pi over 4. Those are our 2 points in polar form. All right, well, that's wonderful and grand. But unfortunately, the jerks want us to come up with rectangular points as well. Okay, so for C, remember that x is equal to r cosine theta, y is equal to r sine theta, right? So that would be equal to 2 square root of 2 cosine of pi over 4, which is 2 square root of 2 times, and in this case I'm going to use this version, so 1 over the square root of 2, which lo and behold is 2. And then this will be 2 square root of 2 sine of pi over 4, which is 2 square root of 2 times 1 over the square root of 2, which is also 2. So C is 2 comma 2 in rectangular form. D, that same point, this is polar form, so rectangular form, x would be r cosine theta, y is equal to r sine of theta. So this is 2 square root of 2 cosine of 3 pi over 4, which is 2 square root of 2 times negative 1 over the square root of 2, which would be negative 2. And then this would be 2 square root of 2 times the sine of 3 pi over 4, which is 2 square root of 2 times positive 1 over the square root of 2, which is 2. So letter D is, whoops, I messed up, sorry. D, of course, had negative, my bad. So it's negative 2 square root of 2, negative 2 square root of 2, because D had a negative in it, sorry, I forgot about that. So that makes this one positive, because it's negative times a negative, which is positive. This one is negative, sorry. So it's 2, negative 2. So these right here are the rectangular points with a horizontal tangent. And you can also see that when you look at it. So let me bring up the graph. So you can see the curve, right? You can see the horizontal and vertical tangent lines, and there they are, right? And if I change the grid system, you'll spot it from a mile away. Let me switch. Hello, 2, 2, 2, negative 2. Right there they are, right there. And then 4, 0, and 0, 0. So we just proved that our rectangular and polar coordinate graphs were correct, and our polar coordinate values were correct. One other thing they didn't ask us for directly, but we could give it to them really easily, is the equations of the tangent lines. So just so you know, the equations of those horizontal tangent lines, well, they're horizontal, so they're not hard. Horizontal lines are y equals, and we just figured out what the two y values are. Right? Look at the graph. Y equals 2, y equals negative 2. I mean, look at those horizontal lines. Of course they are. And the vertical lines, of course, are x equals 0 and x equals 4. We could put that back on the previous page. I know it strictly wasn't asked for. Oh, maybe it was. Oh, it did say, find the Cartesian equation of the tangent lines. We just did it. It was asked for. It's the values of the x's, which in this case are 4 and 0. So we have come up with the equations, or excuse me, the polar forms of the vertical points, points with vertical tangents, the rectangular coordinates of those same points, and then those rectangular coordinates led us to the equations for the vertical lines. Then we did it again for the horizontal lines. We have polar forms for those 2 points with horizontal lines, horizontal tangent lines. We have rectangular coordinates of those same points. And the rectangular coordinates in particular get us the equations for those horizontal tangent lines.